Let's get started off today. We're going to finish off the maintaining skills page for lesson 11.6. This is page 413. We'll do much of this together, so I'd like you to just follow along and have your book open to page 413 so that you can be working on these problems at the same time. I'd even recommend stopping and starting this video as we go along. The first one we'll do, I'll kind of demonstrate, and then I'd like you to pause it, work out part B, and then start it again. And see if you have anything that you've done wrong. If you didn't do anything wrong, go ahead and do C and then D. Otherwise, do just one at a time. Okay, so let's start off with part A. We're going to be multiplying 2/5 times 1 1/3. When we multiply fractions, probably the best thing to do is to make sure that they're both in improper fractions. So I say common fractions or improper fractions. An improper fraction is just a number that should be represented by a mixed number, but will help us out tremendously if we multiply it as an improper fraction. So we'll start by we keep 2/5, and to make this into an improper, we have to take 1 times 3, and then we add 1 to it. We have 4/3. I'm going to real quickly show you how this is true. I'm going to draw one hole and two holes, and then I'm going to cut them up into thirds. Both of these pieces, I'm going to kind of color in this side. This one here is 3/3, and one more third is colored in. So we have a total of 1 whole and 1/3, or 4/3 pieces. So now we've kind of designated what how to turn this into a improper fraction. Let's go ahead and do our multiplication. We'll just go ahead and drop the answer right up here. So 2 times 4 is 8, and then 5 times 3 is 15. If we would have had this as an improper fraction where the numerator is greater than the denominator, then we would go ahead and fix it so that it would be a mixed number instead of just a common fraction like this. All right, now push pause, try to do part B, and then join me again as soon as you've got part B done. All right, back to part B. We're going to change this one into a improper fraction. This one already is a common fraction. It's fine. So we take the whole number, 3, times the denominator, 4. 3 times 4 is 12. Then we add the leftover numerator. So we have 3 times 4 is 12, plus 1 is 13. So we have 13/4 times 2/3. So let's multiply across. 13 times 2 is 26. And 4 times 3 is 12. If you left it there, you might be okay, but I think we can go one more step where we actually turn this into a mixed number. 12 goes into 26 2 whole times with a remainder of 2 twelfths. You could have also written it as 2 1/6 to go that next step beyond. 7/4 times 1 1/2. Well, this one is already an improper fraction. Again, please stop the video and work on C and then come back to this video. 7/4 times, now we're going to make this into an improper fraction. 1 times 2 is 2, plus 1 is 3. We keep our denominator, and then we take 7 times 3 to get 21. And we take 4 times 2 to get 8. We take 8 into 21. It goes 2 full times. That would give us 16 total pieces with a leftover of 5/8. So pause it, work on D, and then come back, and we will work on, you'll see the answer for D, or how to do D. 5/2 is already a improper. and then we're going to multiply it times 1 and 5, 6. We got to make this an improper fraction as well. 1 times 6 is 6, plus 5 is 11, so we have 11/6. Take 5 times 11, we get 55, and take 2 times 6, we get 12. So 55/12ths, or we turn this into a mixed number. 12 goes into 55, a total of 4 times with a remainder of, let's see, 7/12ths is our remainder. Okay, next one, push pause, then come back. Okay, 2 times 4 plus 1 gives us 9/4 times 1/5. 9 times 1 is 9, and 4 times 5 is 20. We could write that just right on up here because that is already where it needs to be as far as an answer. Last one, push pause, then come back. 3 times 8 is 24, plus 1 is 25, so we have 25/8 times 4/3. Well, 4 times 25 really isn't that hard. Think of money. 4 times 25 gives us 100. 8 times 3 is 24. 24 is almost 25, and so we know that 24, like 25, will go into it 4 full times, and we can find the remainder of 4 is left. 4 24ths, and for some of you, it could be 4 and 1/6. We reduced that all the way down. If you got to 4 and 4/24 or 124ths, that's very acceptable. Let's take a look at the next section. This is, well, it's very, very familiar to what we've been working on. The problem says Claire earns up to $8 doing different chores each week. Every week she gives $1 of her money to charity and saves the rest. So you can see she earns each week $8, and she saves a total of $1. Every week she gives $1 of her money to charity and saves the rest. Oh, excuse me. I have that incorrect. Every week she gives $8, or she earns $8, and she may give $1 to charity, but she keeps the other $7 in her bank account for savings. Write 4 different weekly earnings amount in the table below, then show how much Claire saved from each amount. Remember, all earnings must be $8 or less. It took me a second to kind of reread and wonder what was going on with this. Well, I think I've got this figured out. Claire earns up to $8 doing different chores each week. Every week she gives $1. It doesn't say that every week she earns $8. It says that every week she earns up to $8, but $1 of whatever she makes goes towards savings. So if we said that she earns $2 and she gives $1 away, then we know that she would get $1 in her savings. It's $1 for herself and $1 to charity. If she were to make $5, earn $5, and she would give $1 away, she would have a total of, I've got that in the wrong place. She would have $4 put in savings. If she, and we better write this down so you can see this here too, earn $2, $1 ends up in savings. There's going to be a difference of $1 in each of these. Earns $5, put $4 in savings, and we'll do one more. We'll say that she earns $6. Then she's going to keep $5 in savings. We can put this on here, $6 earned, $5 saved. Right there. Graph the coordinates from the table onto the grid. So I guess we did that at the same time. You can almost see that if we were to take a ruler, we could find other amounts that she would have earned along this way up to $8 in earnings. This last section is preparing for Module 12. I'd like you to go ahead and try and use a division strategy to solve these problems. Both of them do have remainders. After you've solved them both, then I would like you to unpause this video so that you can watch me work through it as well. Now pause your video. Okay, so for this first one, I'm going to use the standard algorithm in each one of these cases. I'm going to take 4 into 314. 5 doesn't go into, 5 into 314. 5 doesn't go into 3, but 5 does go into 31, just not a whole amount. 5 goes into 31 6 times. We have 5 times 6 equals 30. Subtract that away, we have 14 left over because we have to bring down this 4. 5 goes into 14 2 full times. 5 times 2 is 10. And my remainder is going to be 4. So 62, remainder 4 for this first one. The second one, I know that it is also going to be a remainder of 2. Or a remainder in this one as well. So let's find out what our answer is going to be. I'm going to go ahead and use the standard algorithm. I think what I'll do is I'm just going to put it right here. That way I can just write the answer right above it. So we have it set up already. 3 goes into 1. Nope, it doesn't. But 3 does go into 15. It goes in an even amount. It goes in 5 times. 3 times 5 is 15. Subtract that away, I've got 0. I drop down my 6. 3 goes into 6 2 times. Again, I got rid of my 6, so I've got a number 8 left. 3 goes into 8 2 times, so 522 with some sort of remainder. I have to take 6 away, so 522 with a remainder of 2.